Hello, everyone. As promised, here is your quiz review. Now, this will be our first quiz that we have where there's going to be some more math in there. I know math can cause some anxiety for folks. I do think it should be it's very manageable for you. And it will follow along with a lot of the material that's presented within the reading, but I know the reading can also be very difficult. So what I want to try to do is do some walkthroughs of some problems that you might see on this week's quiz. So feel free to watch this video. Now, you should be able to be successful in the quiz without watching the video, just by understanding the material within the chapter, but I think this will help. So if you have a few minutes, you may want to take some time to watch this. We'll be walking through about 5 or 6 various type of examples, again, that might be representative of what you'll see on this week's quiz. So with that, let's go to our magic blue graph paper here, and we're going to walk through some problems.
All right, so here's our first problem. We've got the Seattle Radiology Group plans to invest in a new CT scanner. The group estimates that $2,000 net revenue per scan. The preliminary market assessments indicate that demand will be less than 6,000 scans per year. The group is considering a scanner, we'll call it Scanner A, that would result in a total fixed costs of $2 million and would yield a profit of $750,000 per year at that volume of 6,000 scans. What is the implied variable cost per scan for Scanner A? And when you're doing these problems, you do want to show your work. Just don't give me an answer on there. You got to show me how you got the answer when you're doing the quiz. So kind of the basics. What did you add? What did you multiply? You know, kind of step 1, 2, 3, that kind of thing. If you just give me an answer and it's the wrong answer, you won't get any points at all. If you just give me an answer and it's the right answer, you will get some points, but you won't get full points because I don't know exactly how you got that answer. So demonstrate how you were able to produce that answer. And here's the good news. If you demonstrate how you got the answer and the answer was totally wrong, but you demonstrated some thought process, you're going to get some points. So long story short, show your work, you're going to get some points for that, even if it's completely wrong. All right, so that's my little discussion on that. Let's break down this question. This question really is focusing around that equation, the total profit, total income equation, which is, we'll kind of write this down here to get a base here. So that's total revenue minus total expense, and the key is what is expense, is going to equal your total profit. Or you might hear net income used. Don't confuse revenue with how much money you're making in the end. Revenue is kind of what you're collecting up front. Then, of course, you got all of the expenses that come out of that revenue to give you your total profit, or in some cases, you might hear total income used. All right? And then the trick of this question, or the thing that it's really drilling down on, is your understanding of what is right in this area. What is comprising of total expense? Total expense is made of 2 different components. One is the fixed costs, which we happen to know in this particular question. And the other one is going to be called the variable costs. That's what it's really honing in on. All right, so let's work through the problem and see how to solve it here. So the first thing we have to figure out in building this equation is what is total revenue? Is that given here? Well, no, it's not. We know we have a revenue number per scan at 2,000, and we know number of scans. So that helps. All right, so we can figure this out. So we're going to take, again, we're trying to build that total revenue number. So we're going to take the $2,000. We're going to multiply it times this projected number of scans. And let's see, doing the math here, taking my phone out, calculating. Well, you can do that in your head, actually. It will be $12 million. Okay? Great. So we're building our equation here. We now know what total revenue is at 12 million. But we're not done. We got to figure out some other parts here. So we do know the $12 million minus total expenses. Now, remember it's fixed and variable. Do we know anything? Yes, we do know one of those. Total fixed costs are at $2 million. So we can plug that in. So it's going to be minus $2 million. Okay? And hopefully you're seeing that, because remember, total revenue minus total expense. Another way to say that is total revenue minus fixed costs minus variable costs equals total profit. But what we don't know is the variable costs. That information is not given to us. Do we know total profit? Well, let's see. We do. That's given to us in this problem. It's right here and would yield a profit of $750,000 per year. So we can plug that in. Okay? So really now we're just looking at some very basic algebra to find out what those variable costs would be. Well, I think you can do this part. 12 million minus 2 million. That's going to get, I'm just going to say 10 million to make it simplified there. Minus variable costs equals the $750,000. A little bit of simple algebra. I think it's pretty intuitive on how to figure out what the missing variable is here in order to get, you know, if you have a $10 million and you're going to end up with only $750,000, you know that the variable cost has to equal 9 million, let's see, at $9,250,000. Yay! So we found out, we basically have built this whole equation. The 12 million minus the $9,250,000 equals the 700, that's a 7, believe it or not, $750,000. But there's always a twist, isn't there? It is, what is the implied variable costs for scanner A? And we want variable costs per scan. That's the twist. So if you just stopped here, you would be not quite all the way there. So to go all the way there, we're going to move up to a little extra space up here. We got to figure out the variable cost per scan. We've got the 9,250,000. How many scans? Well, we've been given a projection all throughout this particular example of that 6,000 scans per year. So we're going to divide that by 6,000. And if you do that, you come up with, again, the 9.250 million, or 9,250,000 divided by 6,000 scans. let's see, running the math here, that one I will have to use a calculator for, and that comes out to $1,541 and some change, and 66 cents. So there you go. That is the answer right there. So I think you can see it's pretty easy. We're just doing some addition, some subtraction, some very simple algebra here. Just really trying to make sure that you understand, the total profit equation, right up here. Do you really know what that means and what it's comprised of both those fixed and variable costs, and just kind of massaging that formula in various ways. So there you go. That wasn't too bad. All right, let's move on to our next example. All right, let's take a look at our next sample. This one, we are still going to be using that profit equation. So let's write that down before we kind of get started here. It's kind of a reference for you. So I'm just going to abbreviate a little bit, but we've got, that total revenue minus total costs equals total profit. All right, so let's read through this. We've got the radiology group plans to invest in a new CT scanner. Sorry, I'm picking on CT and then scanners a lot here. The group estimates that you're going to receive $2,000 in revenue per scan. Primary market assessments indicate demand will be less than 7,000 scans per year. The group is considering a scanner called Scanner B. That would result in fixed costs of $500,000. Okay, so we know fixed costs. That would yield a profit of $500,000 just by coincidence at that volume of 700 scans. Here's the twist is, what is the estimated break-even volume in number of scans? Okay, that's what we're going to come up with for, the Scanner B. So let's talk about break-even. When we use our profit equation, how is break-even going to even help us with that? Break-even, all that is using our total profit equation and just saying our total profit is going to equal 0. That's all. So we're going to deconstruct these two components here so that we can figure out what is going to get us to 0, break even. Anything above, we're making money. Anything below, we're not making money. The other key piece is we're going to be looking at number of scans. So another way to think about it is we're going to be looking at revenue basically per scan, which we know, and I'll just say times S for scan, minus our variable costs times our scans, running out of room here, minus, and can you think of it? What's going to be minus next? That's right, our fixed costs. And that's all going to equal 0. So again, what I've written here is no different than what we have here, just written in a little bit different format. So what do we know? What do we got? All right, do we have revenue per scan? Because we got to figure out how many scans it's going to take to equal 0. We do, okay, we do know that. The group estimates that our revenue per scan is $2,000, so check. We got that part of the problem. We know that we're solving for scan. That's the one we don't know, is what the number of scans are going to be to equal 0. Do we know variable cost per scan? Let's see, we've got total fixed cost, okay, check. We got that one down. But we don't know our variable costs. So it's really kind of similar to the last problem. We're going to find out what those variable costs are per scan, then go back and solve for a 0 profit equation. All right, so let's see what that looks like. So the first thing we got to do, same steps as we did before. I'll change colors here. We'll go to yellow. And we are going to take our, we're going to solve for that total revenue right now. And we know that we're getting $2,000 per scan. We know there are 7,000 scans, or at least estimated. Running the math on that is going to be $14 million. Okay, so there's part one. Let's go ahead and plug that in and see what it looks like. So we got 14 million minus, let's plug in, well, we got variable costs unknown, minus fixed costs, which we do know, listed right up in here somewhere. There we go, right up in there. Equals, what does it equal? Remember, it's total profit. Again, it might be, you might see net income on there. But in this case, we do know that. We have a total profit right listed here. All right. So we're solving for VC. So we're going to simplify our formula a little bit. I think you can figure out this. We've got 14 million. And we've got 500,000. Let's simplify that. That's going to be 13,500,000. And we're still minus our whatever our mystery variable costs are. And that's still going to equal that 500,000. So I think you can probably solve for that VC right in your head. On what that has to be, and it's pretty easy. That has to be at least, or has to be 13 million. But like before, we got to find out that per scan. So we got variable cost all lumped together, you know, for that, but we don't have it down per scan. So we're just going to simply take that and divide it by the number of scans. How many scans were there? 7,000. And let me take my phone out and calculate that. And looks like we're getting $1,857.14. Okay, so we are close. Now I'm going to open up another page, so hopefully in any of these examples that you're writing this down as we go, so you have these kind of these numbers all like at a nice, you know, your pencil and paper in hand is recommended as you're watching these review videos. So let's open up a new page. And let's take some of that information that we have and populate it into that profit formula that we are turning into that break even. So we were able to calculate, we know the $2,000 revenue times scans, I'll just say S, minus, and we now know that our variable cost per scan, I'm going to round here just to make it a little bit easier, is 1,857. So I'm going to introduce a little bit of error into this, times our number of scans. Okay, so remember what this is, our, going back to that profit equation, this is our revenue, this is our variable cost, and then what am I going to do next? Minus our fixed costs, which were given to us, because they're fixed. Doesn't make a difference. Now, whether we have one scan or 10,000 scans, or one patient or 10,000 patients, we have a fixed expense that we have to eat. And that one was 500,000. Here is the zinger. But we are doing break even. So now we're going to toss out that projected revenue that they had, which was $500,000. We want to know the number of scans that makes this whole thing equal 0. So we're going to do a little bit of very simple algebra here. Let's start simplifying this equation so we can solve for S. First thing we'll do, take that 2,000, and I'll just say 2,000s, and that's what that means. When you don't, you can remove the multiplication sign, minus 157s, and I'm going to add 500,000 to both sides of the equation, so that removes it from this side and basically pops it over here. Okay, so now we're saying what S is going to equal 500,000. Let's say you didn't oh my God, I don't remember my algebra. You could just randomly start putting numbers in if you had to until eventually you get there, and you'll get there pretty quickly. You know, a couple, probably within 4 to 5 guesses, you know, you would probably get that number pretty quickly. Or we can actually do this algebraically correct. And when it's written like this, it's very easy. You can simply subtract the two. And if you kind of remember back from the old algebra days, and that would equal 2,000 minus 2,000s minus 1,857s equals 143s equals 500,000. How do you solve for S? Remember, it's division at this point. So we're going to divide each side of this formula, or this equation, by 143. And that leaves just S on this side, and 500,000 divided by 143. And then that means S equals, doing my calculator out here, S equals 3,400, and whoops, that's 3,400, erase that out here, and 96.5 scans. There we go. So we found the number of scans that it would take to equal 0. In other words, to equal break even. You can check your math on this. So you can take those number of scans and you can go right back up in here and plug it in. Now let's go ahead and do that and see what that looks like. So 2,000 times $2,000 per scan. This is the revenue, times 3,496.5 scans equals, let's see here, looking at my calculator, 6,992,000 minus, do the math here, 1,857, these are variable costs per scan, 3,496.5 scans equals 6,492 and 72, then minus the 500,000. Let's run that math. I mean, visually it looks pretty darn close. Yep, it's close. And remember, I introduced a little bit of rounding in here, so that actually equals 72. I was shooting for 0. Had I carried all my cents out and carried all my scans out all the way out, a couple more decimal points, I would have got that perfectly. But 72, when we're dealing with numbers of multiple millions, we're there. We got it. That is the break even is 3,496 scans. Or you just tell your boss, we've got to get 3,500 scans a year. Might as well even round it up. But there you go. So that's it. Kind of this is taking that profits equation and taking it one step further in your understanding, where you're looking at it as also being utilized for break even, but it's nothing fancy. It's just what's going to give us 0 total profit, and that'll be break even. All right, so there's that example. Let's take a look at a couple of more here. All right, example 4. We can take a little break because this it'll be easy for these next two. 3 is really that third example that we have. That was really kind of bringing a lot of things together. This one is going to be pretty easy for you. So let's take a look at this one. We've got consider the following. We've got some fixed cost listed here at 80,000. Or I should say 80 million. We've got our variable costs per inpatient day. We've got our revenue per inpatient day. And what is the contribution margin? So this is a contribution margin question. So let's break this down a little bit. And it's pretty easy. Don't have to overthink this one. So contribution margin is basically, I'll call it CM. Contribution margin is basically the revenue per unit or whatever, day, patient, whatever you want to call it, minus the variable costs, per that unit, day, patient, visit, whatever it is. But on a unit basis. And that's all we need to do is set up the problem like this. So what is our revenue per unit? Is it given here? It is. Revenue per inpatient day. We want to find the contribution margin. So we know the unit in this case is going to be those inpatient days. So we're going to use that. And we know that is $1,500 minus, do we know the variable costs per day? Yeah, it's listed right here. It's just that simple. And that's going to be 600 in this case. So our contribution margin is going to equal 1,500 minus 600. So that is I don't think I need a calculator for this one, but you never know with me. So $900, that's your contribution margin. It's just that simple. There is a little bit of a red herring in here, and all questions usually have some sort of, little extra piece of data sometimes in there that you don't need. This one has the fixed costs in here. So don't let that throw you if you see that in there. Contribution margin is just simply that revenue per unit minus the variable cost per unit equals contribution margin. But what does contribution margin mean? Contribution to what? Think about that for a moment. Well, I guess the nice way to think about it is it's really the contribution that you are making towards covering the fixed costs. For every inpatient day that you generate, your contribution margin is $900 contributing to, think of it that way, covering your fixed costs. You could figure out how many days would it take, with that contribution margin, how many inpatient days would it take to cover your fixed costs. You could do that. So think of it that way. It's, what does it contribute to? It's the contribution to covering the fixed costs to which you have in that situation. So that's as easy as that problem is. Don't overthink that type of problem. Let's move on to our last example. With this example, we're going to bring back that familiar profit equation. And remember, that is going to be the, we have our total revenue, revenue minus variable costs minus fixed costs equals our total profit. What we want to know in this case is what is the break-even volume in patient days. So that's kind of the cue. Remember what break-even, what did we just say, how to do break-even? It's simply that profit equation set to 0 So we're going to fill in some of the things that we do know. And what is our total revenue? Well, total revenue in this case, we have revenue per inpatient day. So I'm going to list, we have $1,600 per inpatient day. I'm going to use, I've got a variable I don't know, which is what I'm solving for. I want to solve for patient days, so that all works out really, really well. So the variable, the unknown, is patient days. I'm just going to say D, okay? So 1,600 times D, that would equal my total revenue, if I knew what D was. Minus our variable costs, which we do know are $600. That's listed right here. So 600 D, don't know how many days, minus, oh, coming up to something that I do know, minus 11, I'm going to say, put an M in there for million because I don't want to put all those zeros in there, minus 11 million. So all we got to do is solve for D. How many patient days is going to take to reach zero, that break even on our profit equation? We're going to do some simplification here and here, okay? I think you can see that pretty quickly jumping out. That is going to be 1,000 days, or D, minus, well, I think you're good enough we could skip this step. We're going to take the 11 million and we're going to move it to this side of the equation. We do that by adding 11 million to both sides. So it gets rid of this negative 11 million and puts it over here on the zero side. And now, what are we going to solve for? Like I've said, we're solving for D, okay? So you divide by 1,000. That gets rid of that. That gets rid of that. Divide by 1,000. And punching it in on the calculator, that equals, well, you guys can probably do that one in your head. I can't. That equals 11,000 D, days, patient days. So there's the answer. Our break even on patient days is 11,000. And it's as simple as that. So try not to overthink this one. It's just kind of another spin on a break even. So there you go. There's some walkthrough on some potential types of questions that could be on the quiz. Do take a look at those. Hopefully you've taken the time to walk through this and hopefully it has helped. I think the concepts will be pretty similar to what you'll see on this week's quiz. So again, good luck with this week's quiz, and as always, thanks for watching.